This is Engage New York, Module 3, Lesson 9. This is Concept Development. So question 1 for you. How did you decide to use tenths in the first part of our application problem? So in the first part of the application problem, remember when we had 1/2 and 1/5? So 1/2 and then we had 1/5. So it's asking you, how did you decide to use the tenths in the first part of the application problem? Did you break it up? Did you make a rectangular fraction model? How did you do that? So I simply added and I scoreboarded, and then I created my common denominator and went from there. So if we start off with half, right, like we did in our problem, and then when we scoreboarded, we decided to multiply that by 5, right, to get 5/10. So that would be essentially breaking this up into fifths, right, multiplying this by 5. 1, 2, 3, 4. So now I have 1, 2, 3, 4, 5 tenths. So the equivalent fraction, right? We multiply by 5. Then over here, if we had this in fifths, 1, 2, 3, 4, here is fifths. And when we scoreboarded, we decided to multiply this by 2. So when we divided this in half, then we had 2 tenths, right? And that's how we added it up. So what happened to the number of units we selected when we split our rectangle? So when we split our rectangle, we essentially multiplied by 5 for 1/5, and then we multiplied by 2 for the 1/5, correct? So what we ended up doing is 1 times 5 over 2 times 5, right? And then we did 1 times 2 over 5 times 2. Is that correct? And we got 5/10, 2/10. So what happened to the size? So that's really kind of the big idea here. So what happened to the size of this? So we started with half, and what did we do? We multiplied, but when we multiplied, the pieces got what? Did the pieces get bigger? No, the pieces got smaller, or the units, right? The units got smaller. So that's something important to remember. So when I had 1 times 5 and 2 times 5, and I got 5/10, this was 5. Whoops, I'm going to come over here. So 1 times 5 and 2 times 5, right? Let me erase this. And it became 5/10. So the top becomes 5 times as many units, and the bottom is 5 times as many wholes, right? 5 times as many units in the whole. All right. So when we came down here, so right here, I want you to write, let's reflect for a second. So the number of parts doubled. What down here, correct? And when we came up here, the reflection is our numbers got 5 times as many, right? Now here, the units are down here, half as big as before. When we multiplied this by when we multiplied this by 2, our numbers, we actually cut it in half and we made the units smaller. But there are twice as many of them. So let's reflect over here. When we multiplied by 2, the number of parts doubled. So 1 times 2 became 2. So the number of parts doubled. Or 2 times as many. Or 2 times as many. Then on the bottom, the number of units. So you're writing this down, right? The number of units in the whole number, in the whole, doubled because we multiplied by 2. Another way of saying it, or it's 2 times as many parts. So that's what we're doing when we're doing all of this, when we're using our fraction model, making it 5 times bigger, making it 2 times bigger, right? So I'll give you another second to write this down. All right, now let's go to the back. Let's add our 2 fractions together. So 1 times 5 is 5 plus 2 tenths equals 7 tenths, right? Now let's go to a new fraction. So we're going to make this number 10 times bigger. We're making this number 4 times bigger, right? So 10 over 20 plus 4 over 20 equals 14 20ths. But we know that 2 is hiding inside 2 and 7, and 2 and 10 are hiding in. So our simplified fraction is 7 tenths. All right. What do the types of units have in common? What do they have in common? Well, you can multiply them to find a common denominator, right? So 1/2 plus 1/5 is equal to 7 tenths. 7 tenths is equal to 14 20ths, which is equivalent to 21 30ths, which is equivalent to 35 50ths. Now, remember, this is just like times 2 right here, right? This is 7. 7 times 1 is here. 7 times 2 is here. 7 times 3 is here. 7 times 5 is here. All of these are equivalent to 7 tenths. We're just multiplying. Remember, whatever you do to the top, you do to the bottom, right? Oh, this one's 1. This would be 7 times 2, right? All right. So based on that, let's go ahead and solve some problems. Now, hopefully you know to scoreboard if you need to. If you don't need to, you don't need to. 2 times 1, 2 times 2, 2 times 3, 3 times 1, 3 times 2. I'm just going to create equivalent fractions or common denominators. And I'm going to add 1, 7, 6. But I know 6 over 6 is hiding in there, plus a 1 over 6 is and I'm going to get 1 and 1/6. All right. That's not too difficult. Let's go ahead and keep going. So 9 and 6. So 9 and 6. So 9 times 1, 9 times 2, 9 times 3. Let's go over here and 6 times 1, 6 times 2, 6 times 3. Oh, there it is, right? So let's come over here. I'm going to multiply 9 times 2, this one by 3, and I'm going to get 10 eighteenths plus 15 eighteenths, and I'm going to get 25 eighteenths, and I know 18 out of 18 is hiding inside. So what's the difference between 25 and 18? Is that 7 eighteenths? So this becomes 1 and 7 eighteenths, and I cannot simplify that anymore because a 7 is a prime number. All right, but what if I have 3 fractions that I want to work with? Is that going to stop me? No. I can just do it this way. I have 3, 4, and 2. So 3 times 1, 3 times 2, 3 times 3, 3 times 4, 4 times 1, 4 times 2, 4 times 3. Found 2 so far. 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, 2 times 6. So we found our common denominator. Times 4, times 3, times 6. This becomes 8 plus 3 plus 6, and it's all over 12. So 8 and 6 is 14, 15, 16, 17, 17 twelfths, which I know I can pull 12 out of 12 out, and that's going to leave me 5 twelfths. So my answer is 1 and 5 twelfths. So this is our big idea for today. And all of these, I could have put 3 plus 4 over 6. I could have put 10 plus 15 over 18. That would have been okay too, because they share the same denominator. All right, that'll do it for our concept development. Now it's time for you to try out your problems on the problem set. And yes, there are 3 word problems, and you should be able to do those without any trouble. Good luck, and we'll see you next time.